Welcome everyone to this event. This is the first of our XR In series. We're really excited to be launching this to you. This will become a regular event where, from time to time we will be hosting and inviting 3 speakers to come and join us to talk about XR and the applications of it within their industries. So today we have XR in medicine and surgery. We have speakers from industry, from academia, and recent graduates and students. So we are really trying to cover all the different areas and really encourage that that bond between those different stages in education and in life. Stay tuned also to find out about some internships that we have to offer you. They are exclusively for Leeds University students and they are indeed paid, so that's always a bonus. We also have a live prize draw right at the end, so make sure that you stay for that. And we will be talking about our next XR In event, which will be taking place next week. Just a disclaimer, as you can see on the screen, we ask kindly if you please keep your cameras off and your microphones off throughout the talk, and that does not apply to the speakers obviously, but and then any questions that you would like to ask our speakers, please do write them in the chat and we'll have a live Q&A session at the end of each talk. I'm now going to hand over to Mohammed, who is our Vice President and a 5th year medical student, who will be introducing each of the speakers. So, Mohammed.
Thank you very much, Anna. Hope you guys can hear me okay. I'm currently in hospital accommodation, so I'm not sure how good the Wi-Fi is, but we'll crack on. Just wanted to thank all the speakers for giving their time, and also the committee for doing so much amazing work sort of leading up to this event, during the event, and probably after the event as well. The reason why we have these events in sort of a trio of speakers is so that a student primarily, which is who we're aiming for to attend these events, can put themselves in the shoes of the student through the student representative, who today will be Ross, who I'll be introducing in a second. If they want to further their education, they can go into sort of the academic realm within XR today in medicine and surgery. So Gareth will be covering that. And then if for the sort of doctors or people who are interested in medicine and surgery here, then they can look at the possible academic, industry uses of XR within medicine and surgery. And hopefully that's the sort of approach that we'll be having: a student representative, and an academic representative, and an industry representative. So our first speaker tonight is Ross. He is a newly qualified doctor working in Aberdeen in Scotland with interests in critical care research and education. He's done some interesting projects during his time as a medical student, and I'm very excited to hear some of the things that he'll be sharing today. So over to you, Ross.
Thank you very much. So give me that awkward sort of few seconds that I can share my screen. Let me just get the presentation going.
And of course, guys, feel free, I'm just giving Ross some more time, feel free to drop your questions in the chat. We'll be collating them and asking them at the end of the presentation. The presentations are typically about 15 to 20 minutes in length each, and then we'll have about 5 to 7 minutes of questions at the end. So feel free to fire away all your questions and we'll piece them together.
Sorry, I don't use Zoom very often. I'm a Teams guy. Can you see any of my screen just yet?
Not yet. So at the bottom of your screen, you'll find a share screen, a green icon at the bottom of your screen. And then you can decide which screen you'd like to share, which sort of software you're using.
I think we're winning.
That's fantastic. Yeah, if you can just open that up, and then we're good to go.
Yep, cool. Sorry, just needed some passwords and stuff to get it permissions through. Cool. So by way of quick introduction, thanks for that, Mohammed. And great to see so many people here so late on a Friday night. But I guess there's not much else to do these days, so might as well try and learn something. We're going to have a bit of a chat about my student experience with virtual reality in medicine and surgery specifically. So I'm going to talk a little bit about what I did as a project and where it sort of came from, or the things I learned from it, and hopefully that you can take away from this session, and then just some sort of more what's the word? Sorry, I've been working today and I'm fried. Some more sort of abstract thoughts about what you can do in the future in VR as well. So just some little thoughts I've had along the way. But to start off with, can I please just level this playing field? I'm no expert in technology at all. You guys are probably all way ahead of me. And certainly at the start of my project, I could barely sort of record anything on a camcorder because I was just not used to using this kind of tech. So pretty exciting realm to start learning. And in virtual reality, I had to pick up things pretty quickly. But yeah, I'm by no means an expert. I've got no particular sort of qualifications or knowledge about technology or virtual reality in itself. So everything's coming from a pretty amateur level, which I'm kind of saying to sort of level this playing field and make sure that you can access these sorts of things quite easily, and get involved in virtual reality and medicine and surgery quite quickly as a student. So keep your eye open for opportunities and don't be put off just because you haven't got experience in this environment. So like I say, we'll have a chat about some personal experience, some of the things I've learned, and some things for the future, and hopefully it'll be a fairly brief chat. So I looked at the use of virtual reality and simulation training. We use simulation training a lot in medicine and surgery. It's basically just a safe way of practicing the protocols and the procedures and things we need to do without having the risk of harming patients. And there's lots of different elements to simulation training, and lots of different skills that need to be learned. So there's the sort of practical procedures, whether it's putting in a cannula or resuscitating a patient with CPR. But then surrounding that, there's other skills like softer skills, so communication skills, teamwork, and a wide variety of things. And because it's such a broad range of skills that you need to learn, it suits itself to a broad range of media and learning styles. So simulation training was something I was always interested in, and resuscitation in particular, from the medical side of things. And the opportunity arose during my 4th year of med school to apply virtual reality to that context. Now, of course, you shouldn't really come up with a solution and then think back to what the problems it could fit. You should really find a problem and then fit the solution to the problem. But this is kind of where we were landed. So we had this opportunity to apply virtual reality. So we started hunting for problems in resuscitation training in healthcare that might be relevant. And the main issues we found as students is that sort of threshold from student to doctor that I've quite recently passed myself is enormous, and you only really appreciate it in retrospect once you look back. And you go from having pretty minimal consequence and responsibility as a student to then having an enormous amount of responsibility, and ultimately your sort of career and profession on the line, without being too melodramatic. So that was important that we consider the size of the gap between being a student and being the practicing professional, and thought, well, maybe VR could help us bridge that gap a little bit. There's also, as I've mentioned, lots of different elements to simulation training. So the technical skills, procedures, but also the non-technical skills, and how you encourage people to focus on that also comes into the design of the process as well. So if you want people to focus on the communication skills in their simulation training, perhaps you need to take away all the procedural and technical part that people will quite easily focus on and be drawn to, because that's immediately in front of them. And you need to find some other ways to engage the learning process in these other elements like communication skills and teamwork. And how you do that depends on what learning objectives you're trying to achieve. And then there's lots of sort of limitations to resuscitation training and simulation in general. So funding's a big one. It's very expensive to have the space, the faculty, and the time to do these things. They're very labor intensive. Takes a long time to train people to facilitate these scenarios and to give valuable feedback to the learner. And if you get to the end of a session and the learners haven't taken anything away from it, then it's all been a waste of time and money. So with healthcare being sort of more or less, healthcare training being funded by the government essentially, and not particularly by your fees because it doesn't cover much of the cost, this is definitely an important factor that we need to consider as well. And it's certainly something that industry are interested in. So hopefully Gareth and Will be able to tie in some ideas there later on about how this affects industry and academia. So we're trying to think, could VR help in these situations? So maybe a bit more training could bridge that gap between student and professional. Maybe we've found a sort of novel method of learning, which has got quite a broad scope of application. So it's kind of limitless worlds you can create in virtual reality. So there's all sorts of applications we could apply here. We can have people watching videos, watching slides in VR. We can have people interacting with one another in VR, doing sort of simulated cartoon things, which will take away from their hand-eye coordination skills and more towards the theoretical learning. But then the development of haptics and things that we can integrate with VR as well. Perhaps even we could learn practical skills with it as well. So there's lots of opportunity, and we set out to sort of answer, could VR fit in any of those gaps? And then in terms of those other limitations, so cost is probably forever falling. As with all technology, it's getting more and more accessible. The virtuality, as you'll probably be finding with home learning at the moment, is a bit more flexible than having to turn up at 9 o'clock on a Friday morning to your teaching session. So there's a bit of scope for flexibility with timing. It takes minimal faculty. Yeah, you need some experts to develop the materials and to make sure that learners are gaining from it. But actually, once you've developed the resources through virtual reality, they can probably run themselves. And I'll talk a little bit later about why that could be helpful. And then clearly you need a little bit less space just to put on a headset than you might do for running a full simulation in, say, a pretend ward-based environment or something like that. So there's definitely opportunity where VR could help here. There's a very basic sense of the thought process we went to when we were designing this project. So the sort of study format that we ended up doing was looking at senior medical students, so 4th and 5th years. And the intervention we came up with was using virtual reality as a playback tool after they'd done simulation. So the majority of your learning through simulation is in the debrief. So after you've done the simulation and you talk about it or you watch it back, that's when you start to actually learn. And so we thought maybe VR could be used as a playback tool. And we thought we'd compare that with the current gold standard for simulation, which is video playback. So, and we thought we'd measure a few different outcomes. Being a really small pilot study, we sort of went for a sort of cover-all approach where we wanted to measure people's situational awareness. So when they're playing back their simulation, then what do they look at? What do they interact with? And what do they notice in VR versus standard video? And then some more basic sort of qualitative elements, such as what the user preference might be. And we did some evaluation on that. And in summary, what we really found was virtual reality, people were really good at spotting things that they missed. So there's something about them being immersed in the world that they've just sort of simulated that allows people to become conscious of the things that they're not very good at. So that's in the academic world known as conscious incompetence. And it sounds a little bit insulting, but it's actually the best spot for learning, because once you're aware of the things that you don't know, that's when you can start to fill the gaps with your own study. So there's a bit of signal that maybe VR is pretty good at allowing us to do that for simulation. So there's some benefit there. In terms of user preference, it was pretty mixed story. So people like video, it's reliable, they know how to use it. They didn't feel sick when they were using it. So a lot of people preferred just watching the video on a computer screen. And for those who are more linguistic learners, they could write notes and they felt that they could sort of step away from the scenario and have a think. But we found that more visual learners would actually benefit from being immersed in this scenario. So again, sort of horses for courses type thing, where people with different learning styles and actually different previous experiences. So if you've ever used VR before, you were much more intuitive at getting involved in the scenario and using the headset, and you had an idea of what to expect. And so they were much more familiar with it than those who'd never used it before. But again, small study, there's plenty more to be discovered there about what people like and don't like and how you can predict which people are going to fall into each of those groups. And so as a sort of sum up of what their experience was like, people thought the VR was pretty fun and they've never done it before a lot of the time, but they found the software quite challenging, and it was pretty basic where you put the headset on and you press play. But for people who've never put the headset on before and never used the interface, it's fairly reasonable that they're going to struggle with that. And for those with video, they found it very familiar, but some people found it quite distractible. So you could easily switch on to something else happening in the room. And we tried to sort of minimize interference, and we had headphones on and put people in a quiet space. But even still, you know, you can feel people sort of moving around. You can feel the floor moving and things like that. So it's easy to get distracted with video. But you're actually able to make notes or do secondary tasks, which is sometimes what you want to do to gain enable maximum learning. So lots of pros and cons to both. We didn't really find a definitive answer. When you ask 30 people something, you're never going to find out the true answer. But it was a great little fun experiment to give a go. And so that's what my sort of research in virtual reality was. And myself and a colleague took it to the Resuscitation conference in Slovenia last year, which was awesome and had all sorts of benefits as well in terms of going to an international conference. So it's quite a niche topic, and it's a pretty small subject area. And I think that the idea of these sessions, in my eyes, was to open everybody's minds up to virtuality more widely. So I wanted to speak briefly about what I learned from it. And the first was that enthusiasm opens doors. So by just engaging with the medical school on this, interacting with their medical technology team, and just being interested and engaged in the academic process really opened doors for us. Myself and my colleague who worked on it together, and sort of we found all sorts of new opportunities. Ended up running, you know, helping to run careers conferences with some pretty important people in the NHS, and that wouldn't have happened if we hadn't done this project. So definitely just being generally enthusiastic with the people you meet and the supervisors you work with is helpful. It was a great sort of hub and spoke networking method as well that I found here. So it seems to work well in tech, is that you've got everybody's an expert in their own little niche, and you can, often as a student, you can fill in those gaps and you can bridge between these different experts. So I found as a student with a bit of a learning experience as a student, a bit of knowledge about resuscitation and a tiny bit of tech knowledge, actually you could bridge the gap between the experts and the educationalists to sort of bring them together. And then all you had to do is really facilitate the conversation between the two of them. You pull the ideas together yourself as this central hub, and then it allowed you to sort of combine the two areas of specialty and make the most of both worlds. So I think that's quite a nice sort of model for networking. And it certainly meant that I've now walked away with contacts in the industry, in VR, as well as in the academic side of medical education, and also met healthcare professionals who are interested in this sort of specialty as well. Third lesson was you definitely don't need to be an expert to innovate. So I'll highlight again, I'm really not an expert with VR. And neither was my colleague. It was the first time we both used it, but we came up with this pretty quick and simple idea. So when we were doing these simulations, we were recording students, and we were recording them with a 3D camera, 360-degree camera, sorry, which is two 180-degree lenses, and it stitches the images together. And we were using this really complex software, really time-consuming, to inject something called metadata, I still don't really know what that is, into this video so that it was stitched together and you could watch it in virtual reality. And actually, we ended up just binning that off, and we just tried shoving the SD card into the phone and then watching it back. And it worked, and it all stitched together perfectly. You didn't need to do any post-production. And that sort of narrowed our time down from about 6 hours of video production to 30 seconds to take the SIM card out from the camera and into the phone. And that was a pretty big innovation, actually, one that we shared at this Resuscitation Council, because that speed of turnaround for your feedback is really important. So you don't need to be an expert to come up with good ideas. In fact, if you're a bit of an idiot and you just give it a go, sometimes it works out quite well. I found the really hard work, though, was getting from concept to the final product. So the only way we managed that, and the only way that we found that innovation, was by just experimenting. So you need to do prototypes if you're coming up with new ideas. And no matter how rubbish it looks or how many fails you make, that's kind of where you do your learning. So you need to try these ideas and then figure out what's not quite working. Is it the image quality is not good enough? Are the files not big enough? Is your computer too slow? Is the chip too small in it? And so you need to be able to identify those issues. And the only way you do that is just by trying something. So great, do a bit of research and get some ideas down on paper, but the best thing you can do is just try some prototypes, get some feedback, learn from it, and develop. And then my final little lesson that I learned was perfecting this elevator pitch so that you can get other stakeholders to buy in. So if you can convince someone in 30 seconds to 60 seconds that you've got a good idea and that it's got some legs, whether it's for academic output or to make some money or anything like that, then you're going to get much better buy-in. You know, people will switch off pretty shortly after you start talking to them. Now, I imagine you're probably pretty bored of me by now. So if you perfect that elevator pitch and you catch somebody's attention in the first few seconds, you'll really manage to bolster support for your product. And that'll sort of that'll come in to its own, whether it's trying to get a little bit of funding, whether it's just getting technical support, or whether it's getting an academic to commit their valuable time to you to help you with some research. Then, you know, all of these people are going to need pretty much the same pitch. So if you can get it right, it's definitely worth doing. So perfect that idea in your head, make it clear and make it simple. And so as a student, where did I really fit into this weird world that's still formulating and still developing? So I found myself in a few little roles. And so I think these are ideas I'd like to share again. So you can be a user and you can just sort of, whether it's playing games or whether it's being a learner using virtual reality, you're definitely the target for a lot of industry. So definitely a user is an important role. But also you can be a researcher and you can create academic output, as I've managed to do. And that's important as well to contribute to the development of these products. And you can be an innovator, and you can be as simple as putting an SD card into a phone, and it all of a sudden cuts out loads of time from post-production. So students you can fill in any of those roles or all of them, as I've somehow managed to do. Yeah, lots of opportunities for students to fit in. And what's nice is you're not constrained by your role. So I think there's fairly few limits on what students can access and what they can do these days, especially with tech. So you can bring all sorts of ideas to the table. And then a few little thoughts about what I sort of reflected on as I was coming to the end of my virtual reality projects, and I'm not involved in much anymore with it, although it might come back round. VR is growing pretty quickly, and it's only going to become, you know, smaller, neater, faster, cheaper, more accessible. And much like phones, it's going to go from having one purpose, which is just sort of a voice communication, to having millions of purposes across the world. And VR is probably going to fill in that kind of void as well. So people are going to come up with all sorts of ideas that you didn't even think you'd need to do, and then all of a sudden it becomes essential. So there's potential for VR to replicate that sort of process with mobile phones, and it'll probably happen a lot quicker than the 40 or 50 years or so that it's taken phones to take off. And as it becomes culturally more accepted as well. So right now, if you sat on a bus using VR, people probably think you're a bit weird, but give it 5 years max, and people are going to be all doing it on the bus or on the train. And say, you know, people are going to surround you with virtual reality and extended reality beyond that. So certainly VR is going to grow into the world. And with that, it's going to get into education more and more. So Ready Learner One, just a silly little phrase I've put there, but maybe we're going to be learning a lot more on virtual platforms. Perhaps if there's evidence to prove that people learn better through virtual reality rather than flat screens, it might be that your uni will provide you with one in the next couple of years. And as these resources that we are using online to currently prevent COVID, but actually in the future, probably just to reduce costs, reduce environmental costs of travel and things, actually there's a huge scope for VR to fill in that void. And if we can develop a nice crisp software and something that's user friendly, and if you can find a niche that ticks a medical or surgical box, then go for it. And certainly going global. So again, as it gets cheaper, it'll become more accessible in developing countries, and there's only going to be more access to it across the world. And certainly VR in developing countries could actually solve some real world issues we've got right now in terms of simulation and training and education. So there's huge scope for this to grow. So those are just some sort of ideas and reflections that I've had, and hopefully everything I've talked about makes sense. I'm not sure what your format is for questions, but I'm happy to take any, and that's all I've got. Thank you very much.
Fantastic. Thank you ever so much, Ross, for that. It's very insightful. I wish I had listened to this a few years ago. I'm sure it would have opened a few doors for me and made my projects a little bit more exciting than the boring ones that I went for when I was a younger student. We've got two nice questions here, and I had one, but it depends on how much time we have. The first is, are there any medical education VR experiences available for medical students to access at home, sort of online? So there was mention of a ward-based virtual reality sort of session.
Yeah, so I So I'm not. I don't get paid by anybody to advertise anything, and I'm sure there's other providers available. So there are certain companies that offer this sort of thing that you can pay for. It's quite expensive at the moment, and I don't know what I don't know if the university is working on anything in Leeds specifically, but there certainly are platforms available. Some companies who I know the name of are Medical Realities. I think there's another one called Oxford Medical Simulation, and they provide some virtual simulation world. So you put the headset on and you're in a ward, or you're in a theatre or something like that, and you can interact and it's sort of like player one type thing where you follow through a scenario or something, and you can do interventions. I've not used lots of them myself. Again, the focus of our study was on feedback after simulation, so we found a little niche and focused on that. But there's certainly platforms out there. I'm sure if you Google it, you'll find loads more than the two that I've mentioned. And like I say, I don't work for any of them, so I'm not going to advertise them, but there's definitely things out there.
Yep, that sounds good. The second question here is, you may have answered this and I missed it, but if you have no experience with VR, how do you manage to develop the prototypes? Did you feel that you had to outsource it or teach yourself the skills? And what VR skills did you have to teach yourself as a beginner to get comfortable with, especially given that we're medical students?
Yeah, that's a really good question. Really valid. So we sort of cheated, and we used filming. So we filmed in 360 degrees. And so I know how to record a video. So you just plonk a camera in a room on a monopod, and it will film the room in 360 degrees. And that was something that the university already had access to. So we kind of stole that idea from the medical technology, technology enhanced learning team at the university. And then after that, it was just a case of playing around with different VR platforms. So we used Google Gallery, which might not even exist anymore. I think it was getting closed down. And we fired the files into that, and it all sort of rendered itself and worked out. So we got pretty lucky with it. And the prototype was basically really simple. It was just making a file by recording it and then uploading it. So there wasn't any fancy programming. So we didn't have to learn too many new skills as beginners. I think what you're probably hinting at is, do I need to learn some kind of coding language or something? Or do I need to do a course? And there's probably things out there. Again, I'm not the best person to ask because I didn't do any. But I'm sure some of your peers who are more into developing XR ideas and platforms probably got a bit more information on that. So I'm not the best person to ask.
Shall I comment a bit on that at the moment?
Yeah. I was actually about to say, Gareth, our second speaker, who I'll introduce in a second, is actually from the Technology Enhanced Learning Department within the School of Medicine, and he deals with some of that. So, if you can comment on that briefly.
I mean, basically, to develop some of these things, find a friend in computer science who's interested in Unity, and find a friend with a design background who can help you with some of the design elements of it. And I think those sort of three interests and professions tie well together to develop this kind of work.
Yeah, absolutely. So as a society, obviously, we were set up in order to bridge the gap between students, and in order to also provide students with the skills that they need to feel that they can get into this kind of area. They don't feel that they're limited by their degrees, or they're limited by their past experience that may not be sort of technical when it comes to computer science. So we are offering different sort of courses, the stuff that we can recommend definitely for you guys. What I'd say is mention it in the feedback, and we'll work on sort of using the feedback form as a way to propel us in whatever direction our membership sees fit. So yeah, that's a very good question. Thank you for that. I think it's good to move to our next speaker now, Gareth Frith. Gareth is the Technology Enhanced Learning Project Manager for the Leeds Institute of Medical Education in the School of Medicine at Leeds. His interest in mobile learning and assessment has been developing a strategy for teaching using immersive technologies such as augmented, mixed, and virtual reality. He presented at EduCourse 2018 on XR and works for the Center of Immersive Technologies on Education in Medicine and Health. Gareth also leads the academic partnership between Leeds Institute for Medical Education and the Health Education England team. Before joining uni, he worked in information technology and telecommunications at Hewlett-Packard, focusing on British Telecom as a client. So without further ado, I'd like to hand it over to Gareth.
Okie doke. Let's see if we hang on. There we go. Can everybody see that?
Yep, that's fantastic.
Okay, good. Excellent. Well, welcome to everybody. Just to hang on a second, I want to see if I can see on my screen. Right, okay. What I'd like to talk to you a bit about is a mixture of sort of how we're using it in the School of Medicine, what sort of things are around in terms of connections with industry, what sort of research is going on, and what sort of things are interesting to follow through. So perhaps if I press ahead, present it to you, then very happy to take lots of questions at the end if you've got those. So the things I want to cover is what is immersive technology, what is XR, and I'll go through some of the definitions there. Why using it in health? Why use it in healthcare education and training? What's the benefits? This is great, interesting technology, but is it really worth the effort? Do you actually learn anything different by using it? And then, what actual style of immersive technology should you actually look to use in various areas? The first thing, it's quite interesting, if you're medics in here, you should look up this thing called the Topple review. It was commissioned last year for the Secretary of State for Health and Social Care. It was actually commissioned by Jeremy Hunt before Matt Hancock took on the role, but it was basically saying, looking at the NHS in 10 years' time, what kind of things will the NHS need for delivering a good service and a different service and an efficient service to patients. And some of these new technologies like genomics and digital medicine, artificial intelligence, robotics, these are all the kind of things that will come in to the NHS at some point in the future in terms of helping deliver a service. That then raises the question really of how do you train the 1.4 million people that work for the NHS on how to use all these new technologies, which is sort of quite a daunting task if you put it that particular way. And I think you should look at, things like immersive technology is perhaps one of the ways of helping the education and training of healthcare professionals right across the board, not just talking about medics, but nurses, midwives, physiotherapists, radiologists, radiographers, that whole gamut of the technical workforce. So just to look at some of the immersive technologies, we can start with augmented reality and 360-degree video, which is basically looking at an object with something and enhancing that physical object with additional information. We can look at mixed reality, which is sort of at the other end of the cost spectrum, which is using a device like Microsoft HoloLens, which is about $3,000 each, but it actually takes and projects holograms into the rooms, and you can actually project the hologram of a patient into a room and work with that patient and so on. And it's a really interesting technology. Price will come down on that in the future, I think. And then I think what Ross has talked quite a bit about, which is virtual reality, which puts you in in a completely different world, whereas the others are actually, you're still in your world, but can see other enhanced areas. And if you want to look at an example of augmented reality, this is really a interesting little demonstration here. This is a t-shirt that you put on, the wearer puts on, and the person can use an app and point their phone at that particular t-shirt, and that design on the t-shirt acts as a trigger, and it allows you to go into all sorts of different parts of the body. Look at the heart, look at the lungs, look at things beating, you can use your finger over the camera to get your pulse rate, and you can associate that with the picture. And not only that, you can zoom in and out with your phone, and about 20 degrees either side of the straight on, and start looking inside the body. They're actually videos, they're not inside the real person, and sometimes you have quite a job to convince people that you're not actually looking at their real insides. But it's a really good one. And if you look at this company Curiscope, it's really quite a cute example and quite interesting example of how to use augmented reality as a trigger. You can also use these kind of things with, this is clinical skills in St James's as it was. You can record things, you can put a hotspot on there, like the little camera that's on the back wall. You can see, if you click on that, it will run a little video by an expert talking about what should happen in a particular procedure and things like this. And also you can put objects in, like those files, you can click on those and it will tell you more about them. So that's an interesting use of augmented reality. Same here with the crash trolley. We've got a resource where you click on that and it starts going through the various drawers of the crash trolley and tells you what's in each drawer and how you use it, because believe it or not, each trust has a different organisational arrangement for the inside of its crash trolleys. So if you go to Bradford on clinical placement, you'll learn a different way of doing it from if you're in Leeds and so on, which is sort of helpful to be able to standardise these kind of things. If you look at then mixed reality, we're talking about having holographic images. So we've got a relationship with a company called GigXR who have some holographic patient cases. There's a case of patient who's come into A&E, is not looking well. He's fallen off his bike. He's had a cut on his back, stitched up and sutured. Looks okay. You can walk around the patient, have a look at it. You can look at his vital signs, so it's displayed up in the headset for you to see on the left. You can start to look at it, and as it progresses, this patient is getting seriously iller by the minute, and it's putting pressure on you to come up with a diagnosis and really, it's actually a case of the patient being allergic to the penicillin somebody's given him without really checking whether he's allergic or not, and it does put you under pressure, and it really helps. And you can do this in small group teaching groups as well. So you could have 5 or 6 people all wearing the same, wearing a HoloLens, all looking at the same image, which is really quite good as a sort of small teaching group. So that's an example of that. If you're looking at anatomy teaching, this is from Case Western in the US, and they built a new medical school, forgot to put in a dissection lab, and so they built it all virtually. And this is, having a look at the various layers and being able to peel them back. Case Western are obviously quite well funded because they've given every first-year student a $3,000 HoloLens to be able to do anatomy remotely. But perhaps Leeds will get that money sometime, but not in the near future. But you can see how you can project those holographic images, and you can take off the various layers and things like that. So it's a really quite interesting technology. This was the anaphylaxis case I was just talking about, and we also do some work with Thessaloniki. We have a visiting professor from there who is looking at neuroanatomy and pathways between the brain and, say, the arm and the hand and things like this, and you can see all these in mixed reality. A really clever bit of mixed reality, which I think is really quite exciting, but who knows, is that you can actually take say an MRI or CT scan image, bring this into the headset and then overlay that as you look at the actual patient whose MRI scan you've got, you can actually see the underlying tissue and layers. And this is a good example that we've tried in Leeds at a neurosurgery boot camp last year of, for people planning the particular operation of, say, taking out a cancerous tumor, a brain tumor or something like that. So, it's really a quite interesting technique. Works really well for neurosurgery. Slightly more challenging for things like cardiac or thoracic work, because obviously in the chest you've got lots of things moving around all the time. So whereas in the brain everything's fairly static. So just think about some of the downsides of some of these things as well, because potentially there's opportunities to fix those. And the final bit was really looking at virtual reality, and this is I think it's interesting because it's a very good low cost entry level environment. We've got these little cardboard headsets here, all branded up with University of Leeds on them. You put you create the virtual learning example, put it on your phone, put the phone in the cardboard headset, and there you are. You've got a headset with virtual reality on it. And we've certainly done some interesting work with medical realities around a tour of the histopathology teaching labs in St James's Hospital. And you say, well, couldn't I just pop in and have a look at what goes in the lab? Well, we can't take 250 students in at once. We can't take anybody in at once at the moment, but yet we can take you what probably is a 90–95% experience of the real thing by doing it in virtual reality. So it maybe is not as good as the real thing, but it's 95% is a lot better than not doing it at all. And I think it's very interesting to have a look at those sort of examples as well. So we've done some research on that as to, do people like it in a headset? Do people like it on a tablet or flat screen or something like that? We can do that on slightly posher headsets, but the cardboard one is really quite good. Given how simple it is, I'm surprised at how the quality of some of the stuff we get out of that. There are then, I think somebody mentioned Oxford Medical Simulation earlier. They're a company who does a lot of this stuff. They do it in actually CGI rather than filming, which is another option to have a look at. We're probably going to get access to medical reality surgery work, which is, again, that's filmed. We're probably going to do some surgery filming for obstetrics around C-sections, which again has some very interesting applications for international health, because actually learning how to do C-sections and complicated C-section operations is really something that's badly needed in some of the international, especially Africa type and India type medical environments. So watch out in this space for these kind of ideas and how they build up on that. We hope to do that fairly soon, because as you all probably realise, C-section is not an operation you can easily cancel. So we're hoping to be able to get a camera into one or two of those operations fairly shortly. The other thing we've again done is to look at sort of orientation of, and this is an example we've done of orientation in the cardiac theatre, operating theatre in LGI, and it takes you on a complete tour around, and it tells you who's who in the theatre and things like this. We were fortunate enough to be able to get all the staff into the theatre without actual patient there, so that we could film all that. and that really helps you keep your skills current, because with a low entry cost level entry, you can just do that revision, if you like, with cardboard headset, your phone, in a quiet period. There are more complex parts of virtual reality, and this shows a Virtuality headset with hand controls, and usually that comes with a, you can actually see it now has a wire coming out of it that will plug into a fairly heavy duty desktop computer or a very chunky laptop to drive all the graphics and so on. But again, you can think about how you could use that in terms of practicing for surgery training, practicing hand movement skills, all that kind of thing, and that again could be really helpful in that sort of environment. So let's have a look at how we actually do the research and evaluation on this. It's really what size groups can we deliver teaching to? Well, in the undergraduate medicine degree in Leeds, there's 270 students in each year. So how do we do that? You can't, unless you've got the kind of deep pockets that some of the American university has, you can't go out and buy 270 HoloLens devices at the moment, because we haven't got the money. Whereas you could go into, say, VR and do something quite interesting that would work on your phone and in a cardboard headset. Personal teaching and personal revision, that would be great for. Small group teaching, however, the HoloLens really comes into its own, because you can get a group of 8 to 10 students all working together with a tutor and interacting with that same holographic environment and patient. So that would be something to look there. And then, the million-dollar question is, does that immersive tech improve your learning, and how do you find that out? And this is some of the things I've spent most of today talking to HEE about how we can evaluate this work. How can we actually prove that it helps? How can we prove that you learn something with it? And how do we calculate the return on investment of all the work that perhaps goes into this? And again, asking the question of, is it worth the effort? And I think by and large, it certainly is, even if it's something which says it's not quite as good as the real, thing, but it's an enormous amount better than not doing it at all. And I think sounds a bit negative, but think about it. It's something which in a program of teaching you can really introduce as a sort of pre-class type work, and then go into the detail with face-to-face. So it helps you with that reach that we've got. We're doing some work in LTHT around a renal ward round. We've just done a filmed ward round in basic surgery ward round. I think it was shot in Huddersfield. We're thinking of doing some surgery teaching projects, both in technical terms of, say, kidney transplant surgery, where you can get 2 or 3 students in to watch that, but not a very large number. And also looking at non-technical skills. There's a view that perhaps the technical surgery skills, there's a lot of resource out there for those, but not necessarily for the non-technical skills like comm skills and that side of things. So really, that's the sort of these are the sort of things that we've been working on and we've been engaging with. And I think I think people have mentioned earlier, costs will come down. There will be a move from big chunky headsets like the HoloLens into more glasses type environments. There's a Chinese company called Nreal, which is potentially in 5 years' time might come along with some interesting glasses projects that actually project things into your into your line of vision as you're doing things. So lots of development and things like that there. Again, you know, the biggest challenge, I think, is actually proving that you know, there's some kind of learning gain and valuable experience in working in this area. So I'll stop sharing my screen now and ask to see if there's any questions.
All right, Gareth, thank you ever so much for that. Very, very insightful, quick whistle-stop tour in terms of
sorry,
what's
it was
happening.
a whistle-stop tour.
But it was really good. I like the breadth of content and examples, which is good, opening as many doors as possible and examples for the attendees. We've got a question here asked that may be more relevant for Will. I'm not too sure, but I'll ask it anyway. It says, how long in the future do you think is it going to be until surgeons are able to practice operations from overseas, controlling robots and equipment through XR? So surgeons overseas using XR for robotic surgery. Well,
I think Will can perhaps answer the robotics question on that, because it's more med tech than my view. But there has already been done, you know, a lot of work done internationally by companies like Medical Realities of reviewing, you know, doing case reviews and things like this worldwide. I think they did one of the first video case reviews with people in Africa and America, and you know, their clinical lead Shafi Ahmad in Barts doing those kind of things. So, you know, there is a sort of general trajectory in that way. I don't know whether Will can answer the, but you know, as somebody whose background is in telecommunications, I'd have a slight worry about how reliable the networks are.
Yeah, absolutely. I mean, I fully agree with you, Gareth. That, yeah, the short answer is it does happen. It's happened already, and it happens very occasionally now, mainly in a research and development setting. It doesn't routinely happen clinically where we teleoperate, remote operate. So the two things really, as Gareth is saying, you know, is the connection needs to have fast, reliable connection, and certainly as 5G comes into play, I think that's going to be a huge part of it. But then with the robotics side of it, you need a robotic system that's compatible with it. Most systems are, or at least can be. I guess the main question is need. You know, why do you need to have so much distance between the person? You know, I guess it's nice to be able to, but it would be better if we can train surgeons to use the equipment there and then. So I think the short answer is it's technically possible and it does happen. I don't know exactly where its role is going to be moving forwards, though.
I think it's interesting that I think in the last couple of weeks, the telecom companies have just started the process of the specification of 6G. Now you might say, well, they haven't actually rolled out 5G properly yet, but
yeah,
it does take a number of years. So they've just started that in the past 2 or 3 weeks, and things like 6G, which will be really high bandwidth networks, will really help things like this. And look more closely, and I don't know whether you've got a session coming up on this, but the Internet of Things is a concept which is going to be really, really helpful in the medicine area in the future, and it's worthwhile keeping an eye on that.
All right, thanks a lot for Gareth and Will for that. Well, I'll ask one quick question. It's a bit complicated, I must say, but they say, how real is your emotional response to what you see with VR? And can this help doctors to manage their emotional responses to the real thing in real life?
Interesting that.
I can tell you a really cool story on that, if you like.
Yeah.
Is that when we were developing the VR tool that we used for the simulation, is we were just in someone's living room and we recorded the room, and then we watched it back in the same room with the same people in the room and the same lighting, but with the headset on. So you're almost like immediately re-seeing the room that you've just been in. And it was the strangest experience of deja vu, because it was so immersive, and because the room was sort of the same temperature and the floor felt the same under your feet. It was a really odd experience. But with VR, what you don't realize is how your other senses become heightened. So the things that you smell and the things like the temperature and the breeze coming through the room, you start to notice as well. So actually, it's quite a realistic experience and almost freakishly real if you're in the same room that you film something in. So I think it's probably quite sensitive. I don't know if anybody else has got any thoughts on that, but
I think that's the case, and people seem to react differently to it, I think, as well. You know, there are some people who can't cope with that, and there are, you know, a number of people who you know, really take to it well. So, whereas, you know, the mixed reality stuff, you can still see the room that you're actually in, so it grounds you more than. But even that, I think you still get very much involved in the. For anybody who's seen the mixed reality things, you know, you still get very much involved in working on that. So, you know, the work we looked at with the anaphylactic patient, one of the things we came out of that thinking was actually we can interact, as in walk around and look at the patient, but it would be great if we could actually speak to the patient and ask them questions and things like that. Now, given that the HoloLens is actually a headset with a whatever Microsoft's voice response system is, I can't remember what it's called at the moment. You know, Microsoft's equivalent of Siri or something like that. That's right. Yeah, thank you. Then you know you actually set up the Microsoft HoloLens by speaking to it. So why couldn't you do it? Why can't we develop some things like that where you actually start to interact properly with that patient?
Yeah,
so it's quite interesting.
It is. I knew that the answer would be quite meaty. I have just a quick addition to the first question. There's a company called Proximi, which someone called Ben in the chat kindly mentioned. They are bridging between surgery and sort of remote support of surgeons, sort of surgeons helping each other remotely using XR. I would recommend you check them out. So that's Proximi.
Yeah,
and the second point, yeah, they're very cool stuff. I think it's definitely going to be part of the future of surgery, I think. Sort of what, you know, the mantra is, why should a patient be limited to a certain standard of care just because they're in a certain area geographically? So it's all the whole idea of international collaboration and so on. And the second question about emotional response is definitely a growing area, but there might be more training about emotional connection to the VR world compared to, you know, the real world kind of thing, and some of the issues that VR may bring in the future if it becomes more mainstream. I think that'll be part of the standard primary school education and probably training for surgeons as well, so that, and doctors and anyone who's using VR, so that they can form this sort of dissociation between the real life, if you like, and the virtual reality sort of limited experience and so on. It's almost like kids watching TV for a bit. They don't become sort of too drawn in. But
I like how closely you affiliate that with the surgeon training as well.
Yeah, yeah. That so that sort of sums up the second talk. I'd like to thank Gareth for his time and move to Will. Will is a man who doesn't really need much of an introduction, but I'll do anyway for the sake of formalities. Dr. Will Bolton is a clinical researcher focusing on innovation and technology for surgical care and training. He is ACIT Innovation. He is in ACIT Innovation, where he brings technology opportunities to surgical trainees across the UK. In his PhD, which is recently finished, he explored the evaluation of surgical innovation in low and middle income countries. He works with industry and researchers to explore how immersive technologies can improve training and healthcare delivery in the NHS and global health contexts. So, Will, it's my pleasure to hand over to you.
Thanks very much, Mo, for that introduction. Just going to make my screen big. Yeah, so congratulations, Mo and Anna, for organising this amazing event. I'm amazed that so many people are here and joining in the lively discussion on a Friday evening. So congratulations on that. So a couple of the themes I'm going to touch on, there's overlap between the three speakers. And I think that's good in a way, because it will give you a different perspective. My perspective and biases are around surgery and surgical training, although a lot of the technologies that we discuss are applicable to a wide variety of healthcare training, indeed, even outside of healthcare, of course, you know, pan specialty. And and I do work for a few organizations, which has led me to foster collaboration with certain industry partners. I don't actually get paid by any of them, but they do feature prominently in my talk. Please feel free to email me and follow me on Twitter if you want to keep up to date with the latest stuff that we're doing. So just some declarations, some of the groups that I've worked with. I started off really as a medical student at Leeds in MedTech and Innovation. The group we founded is called MedTech Foundation, so do check them out. I've kind of stepped back from that now. Just finished a PhD in global health, and one of my chapters in my thesis was looking at virtual reality to train surgeons in Sierra Leone, which I'll describe some of the details of. I'm faculty rep for the Leeds XR Society, which is great, for the medicine and health faculty. And then I've used the innovation skills I've developed to help different organizations, including ASSET, which is our professional body for that represents surgical trainees in the UK. It has 4,000 members. So I help them with some of their innovation strategy, which obviously Immersive Technology features quite heavily. Same with NANSIG, who are a neurosurgical student interest group, and GASOC, who are global surgery and anesthesia and obstetric collaborative group. So please feel free to check them out. They're all amazing teams. For those of you that are medical students in the audience, I guess you recognize this mantra. I certainly recognized it, and I only graduated a few years ago. This idea, this notion of see one, do one, teach one, has and still is to an extent how doctors, how clinicians get trained, and in surgery, which is particularly craft-based and practical skill-based, there is this idea of you sort of watch someone do it, have a quick go with a bit of supervision, and then that means you can crack on, which obviously isn't great, although it does tend to happen. And I think that when we're consultants, the medical students on the call now, in 10-20 years time, we'll look back and actually that will be pretty heavily frowned upon, because we'll have better options. At the moment it's very difficult. You can't really simulate an operation properly yet. There is a first time that you do it, and it is on a patient. It is on Mrs. So-and-so or Mr. So-and-so. And when you start off, you're not that good, and then you get better. That's what the learning curve is. But as soon as we can, and we should be working hard, the people on this call should be working hard to develop the technology necessary to improve that. So as soon as we can simulate and learn skills safely in a safe, scalable environment to prevent our patients being the guinea pigs, I think that's what we should all be aiming for. There's this other notion as well, surgery, like lots of things in medicine, even taking a history from a patient, non-practical skills, say, or breaking bad news or something like that. You can read about how to do it. You can get your OSCE, your mark sheets from your OSCE, and say the things that you need to say to get the points, or whatever. And you can remember all that as much as you like, and you can practice with your mates in your rooms and stuff. But it doesn't work until you actually start doing it. A lot of the time you really learn best when you do. And operating obviously is a pretty obvious example, but I think it's across lots of different areas in healthcare. You need to experience it to learn it. It's exactly like swimming. You can read a book about swimming, you can talk to someone about swimming, but until you get in the pool and start swimming, it's very difficult to click and know what you kind of have to do and how you do it. So simulation is sort of hopefully trying to bridge that gap, I think, into giving people an experiential side to learning, which is very difficult to do outside of just working with patients. And I don't know if any of you have ever, had this feeling when you're, I remember when I took blood for the first time in second year, had a GP surgery, and then now doing small procedures or whatever as a trainee and whatever. There is this notion of, it's really scary doing it for the first time, and taking blood for the first time. Now, obviously, we have to do it all the time, so I don't really think about it. But the first few times it was quite scary. What if I make a mistake, or what if the patient jumps, or, and you just have to get over it. So there is this notion of, if you could train and be more confident by using a simulator, wouldn't you want to do it as well as your patients? And I think I would. I'd much rather practice on an excellent simulator or or in a safer environment, I guess, before I just get let loose on a patient and scare both myself and them. And a couple of these reports, have been mentioned in the talks. The one on the left is the Topple review, and there's also for surgical-minded people, there's a Royal College of Surgeons Future Surgery report, which was published a couple of years ago. I'd recommend having a look at least the summary, the executive summary of both of those, if you're interested in technology and healthcare. And as the previous two speakers have, already laid out, it's critical that we think about how we're going to use these technologies, both to train and deliver care. And really, it's important, although a lot of the examples I'm going to talk about are surgical training, or in training, because I am a trainee, and so that's kind of why it's interesting for me, I guess. But you can also use this technology to deliver care, so professionals can use it, but also patients themselves can use it. It's not going to be too long until I'm sure this technology will be used by patients to improve their own healing and understanding of the disease and so on. My brief was to talk a little bit about industry collaboration and the side with industry, and I think these are the kinds of groups of people I talk about that are important to collaborate in any project, really, with technology or in academic medicine, I guess. Your academics and scientists, so the university essentially, they have the discovery science, they have some of the cutting edge skills and expertise, and huge amount of know-how, powerhouse of knowledge. So you need to collaborate with them, because they'll be able to answer a lot of these questions, around which platforms to use, coding, all that stuff. There'll be someone somewhere in the uni that can help. Then obviously, if you're not a healthcare professional, then you need to collaborate with some clinical partners, and don't forget the patients, of course, as well. Always try and involve patients and public in your research. Governments and policy is a bit nebulous, so you want to scale that. If you're a medical student, then it might be whoever's in charge of your policy, so your school, your supervisors, making sure that you're not doing anything, kind of getting them on your side. When you do get out into the when you get into a postgraduate setting, it might be the hospital managers or whatever, but ultimately, you do want to make sure that what you do is on the side of all the policymakers. And then finally, critically is industry, and collaborating with industry responsibly is really, really key. Some people, particularly medics, find it a bit hard to collaborate with industry because they think they're trying to privatize the NHS and steal all the money and stuff. And the reality that just isn't the case in reality. Even if that's what you were concerned about, you need to be able to work with them properly to prevent that happening. But the truth of the matter is, the NHS is one big mixture of different companies working together ultimately to provide services. So you need to collaborate with industry, and it's going to be ever more important. So I'm just going to give you a couple examples of where I've worked with industry and immersive technologies to deliver a project, I guess, in a research setting, because that was most of my experience. And then I'll talk a little bit about a few other types of industry partners you might want to explore, and then a few sort of considerations, I guess, to try and make any industry collaboration you foster successful. As I said, all the examples I'm giving are sort of in surgical training, but that's just because that's what I feel more comfortable in, what I know more about. But there'll be other groups doing similar stuff outside, of course. So the first study is relatively hot off the press. I actually only presented this back in October at an RCS, Royal College of Surgeons meeting. And this is the results of a feasibility RCT that we ran in Sierra Leone almost exactly 12 months ago, which is scary to think it's been that long. So, and called the VITAL study. So here, globally, there's a huge lack of healthcare professionals, and it's really pronounced in surgery and affiliated specialties because of the need to, train someone in a practical skill. It takes a really long time and costs a lot of money to train people to do surgery safely. And we were really interested in, can we find an industry partner? Can we design a study that will start us off on the road to seeing if this technology can even work in a very low resource setting? And Sierra Leone is just the country that we were working in, one of our partner research organizations in the capital there, Freetown. They have some postgraduate surgical training, and some NGOs come in and deliver surgical training. And we were all keen to explore if technology enhanced learning is even feasible there. And just in our research before we even started, almost every single trainee that we could have sampled had a smartphone. So the penetrance of smartphone technology is far greater than the penetrance of surgical training. So we thought, well, we need to find a technology solution that just aligns with the existing tech. We don't want to have to give everyone very expensive headsets. We want to be able to use, their own phones and then maybe a low-cost headset. And the University of Leeds was where our research, where we're based, I guess. So, and they already had a fantastic working relationship with a company who's already been mentioned called Medical Realities, and they're a mobile phone-based product primarily. So they're an app. You can download the app, just use it on your phone, and you can get a very low-cost headset off Amazon, for less than £10, basically, that you can just turn your phone into a VR headset and walk through surgical procedures and learn about them, I guess. So the study aims, a feasibility study doesn't set out to decide that the intervention is effective or not. It sets out to see, is the study design even possible? Are you able to recruit people to this study? Are people willing to take part? And then, what do you think the results might suggest if you had a larger sample size? And typically feasibility studies are around 30 people or 30 participants. You don't normally need to go any bigger than that. So the aims are that, therefore, to see if it's feasible, if we can even do this. And if you look on the right, there's a flow chart of participants which showed that we could recruit everyone, and only one person had to drop out due to clinical duties. Essentially, we gave one group a week before a course, we gave one group the VR modules, which they downloaded on their phone and used and sort of engaged with, versus the other group that didn't receive the VR. And then they came and did a course, just like, a lecture series, I guess, with some practical sessions. And then we did an exam, a mock OSCE and a written exam. And we tried to see if there were any differences between the two groups. And we were able to do the study. People engaged with the technology, which was great. We did a focus group afterwards, just talking about how we can improve it for next time. What other modules they were really interested in. So the module we did was lower limb amputation, because it's just really common, but there's plenty of hard hitters out there. So C-section, as Gareth mentioned, is the commonest operation on the planet, so that's very key. Laparotomy and so on is also really important. And the results, we got people practicing in theatre and stuff. We got some really nice testimonials, which was great from a qualitative point of view. And then these I haven't presented any p-values here because obviously it wasn't a powered study, but what you can see is that the VR group, it does suggest that having the VR does improve your training, which is really exciting. The reason why we did this study really was to see if it's, we need to put some evidence behind this, because as Gareth said, people want to know, is it going to improve the situation before we invest, in this as a technology tool. So we wanted to start that off, and this feasibility study shows that a bigger RCT is possible, and that's exactly what we're working on right now. In my other role as asset innovation lead, we work with Proximy, who's another company that's been mentioned, which is great. So Proximy is a platform technology company that exactly like some of the comments we're mentioning. They are a telepresence company that connect people from distant locations together to virtually scrub in essentially and mentor each other through a procedure. It could be used in conjunction with the robotics, but it's essentially a telecommunications company in that sense. We work with them because Asset normally run over 50 courses each year to our members and stuff, and we just weren't able to do that when COVID hit. So we've just converted them all into online formats, essentially, some of which require immersive experiences, such as anatomy, some of which just require this telepresence that we've kind of got almost through this platform here. So if you cheeky plug, if you aren't an Asset member and you do want to become one, it's an absolute bargain for medical students. So do join us, and you can access the library for free or included in your membership. So this is just an example of one of the ones we did back in July, where we just did some ENT anatomy, and you can see that in real time you can like dissect virtually through the images, and you can discuss the different structures that you're seeing, and people can engage and ask questions, and it's it's just nicer than just reading a book. And you know, they have done some study. We haven't done them with them, but approximately have some evidence behind it that shows it improves skill acquisition and knowledge, which is really great. This is just some pictures I got off the internet. I'm not going to lie to you. This isn't us, but this is an example of what they do. So you can see that it needs a decent amount of hardware, and it obviously needs fast internet connection. But you can have one team doing cleft lip in a low and middle income country context, and you can have in real time someone like a remote surgeon. You know, you can see their hand. They can guide where you want to make the incisions. They can guide what you're doing in real time, which is really powerful stuff. And I'm not even sure I'm allowed to show you this, but Asset have got a collaboration with Medical Realities, which is still very fresh, very hot off the press. You can't quite access it just yet, but another excellent reason to become an Asset member is we have a partnership with Medical Realities to access some of their content for surgical training, which is really exciting. And we hope to get, you know, to break down one of the barriers, which is, you know, getting some kind of headset to turn your phone into a VR headset. We're hoping to provide some of those, which is really exciting. So just some other companies then who I've either used or sort of seen in action, just to give you a few other names, I guess, to explore if you were interested in terms of collaborating with industry or exploring products for your own learning. And they just all touch on slightly different things. So touch surgery is, you know, you kind of look at it through the screen. It's normally a flat 2D screen, but you can dissect through, you can touch through, you can interact with it, you can practice the procedural steps. So it's a slightly different type of XR, I guess, but still really cool. Very successful company. Another company called Apiclar. These guys basically mainly use the HoloLens, which is obviously a very expensive piece of kit, but as you can see here, they're able to do some very powerful stuff like, you know, you can imagine this is being overlaid on a patient's head in real time for intraoperative imaging, and you can cut through and see the structures that you need to see before / as you operate, which is really exciting. Fundamental surgery, they've got they do some work with the Royal College of Surgeons. Now these guys I really like because they use VR. As you can see, she's got the trainee has a VR headset, but then they also have some extra pieces of hardware that provides the haptic feedback. So these are virtual instruments that she's holding here, so she can actually do a knee replacement and it will actually feel like she's doing it, if that makes sense, or at least it's aiming to go some way to feeling like a real operation, which is really exciting. And I think this is kind of the next step here. And then another good thing about them is, you know, particularly with COVID, you know, we're not able to even get into skills labs a lot of the time. So home VR is something that we're really interested in trying to foster for trainees across the UK. You know, there's no reason why you can't come home and rehearse cases and stuff. The technology is getting there, which is really exciting. So a lot of what I've covered so far has been training, and just moving on to giving you the sense that it can be used for more than just training. And this is a piece of research actually done by the team at Leeds. One of my colleagues, Tom Pike, who's a liver and pancreas surgeon at Leeds, and Martin Williams and a few of the team at the Centre for Immersive Technologies were his supervisors here. He basically showed that, you know, if you rehearse operations, your complication rates go down. Which sounds obvious, but no one had actually kind of done it in quite the rigorous way that he did, which was really good. Because what it means that we're going to get to a stage where the time that you actually operate on a patient won't be the first time you've ever done that operation on that patient. You know, we'll get to a stage, not in the too distant future, when you'll be able to upload patient-specific images and do the operation on that patient with their real anatomy. And you might do it a few times before you do it for real life, you know, to practice the critical steps or to navigate critical anatomy. And, you know, you can combine this as the person on the right is doing with a haptic simulator as well, which I think would be an important next step. You can also use it to actually guide your surgery, guide your procedure. And, you know, we already have image guidance in neurosurgery, as Gareth was saying, because obviously there's some critical anatomy there that you don't want to hit. and the head is a fixed space. But if you look at the surgeon who's actually doing the mock-up here, you know, he's got a HoloLens on. You can actually overlay a lot of this information as well, you know, so combine the XR with the neuronavigation that you've already got here. And when you do that, you're able to get images like this, where you can see the patient's real head, you can see the patient's images of the actual brain, and you can actually see where the tumor is, which is just, you know, phenomenal image guidance for, you know, getting excellent margins with your tumor and making sure that you avoid chopping out healthy tissue, which is really, really key. And, you know, you can see this patient's head is pinned by a clamp here, so it holds it nice and still, so you know where things are, but which is important for navigation, but it's not limited to neurosurgery. You know, there have been in research settings the use of overlay, image guided overlay on soft tissues or on other tissues. So this is the liver or the abdominal cavity. Here's some of the critical structures around the liver and pancreas, and you have to have real time registration. So you can, on your laparoscope, you can have devices that allow you to know what you're looking at, know exactly where you are, know where the images are, and overlay in real time, which is really, really cool. So obviously from a learning point of view, but also from a whether this bits the tumor or this bits the pancreas is really critical to know, I guess. So I think still in a research setting, but definitely the future. And then finally, just a few other areas really. I saw this paper, I think this was only a couple of months ago now, but consenting patients for surgery or any procedure is absolutely essential, obviously, and you do your best to go through it all, but it's really difficult to explain what they're going to go through, and for them to understand it in a truly informed way. And so can this technology be used to help improve the consent process, and do patients like it, and so on? And there's this reference here, this trial, which showed that the short answer is yes, but obviously how to implement that's still a question. So I think that's really exciting. Rehab and sort of preparing for and then rehab when you're in ICU is really, really key. There's this growing body of evidence that shows it reduces ICU stay if you use simulation pre-admission and also during admission, and also reduces delirium, which is really exciting. And then finally, rehab and physiotherapy. You know, can you use immersive technologies to improve function after surgery or after injury, which is really, really exciting. You know, the key here is seeing if patients can and want to use it, as well as, you know, does it actually work clinically? So just a few final thoughts really on collaborating with industry. First thing to say is overall it's really, really rewarding to do it, and I would definitely recommend considering finding an industry partner in your ideas, because it really helps to advance your ideas. There's no point, it makes no sense just reinventing the wheel. You know, if a company can do something that you want to do, in my opinion, you know, unless you've got a specific interest, I would just get them to do it for you. But it can come with quite a lot of challenges. So first of all, you know, think about what the right partners are. What you know, for our Sierra Leone study, we had to make sure that we get a mobile phone based solution, that it was, you know, relatively low cost, that it was very robust, you know, it could be used across a broad range of platforms and so on. There's lots of different considerations there. Funding is always critical. You know, who's going to fund this project? And if you're producing content, so we produced some videos, we produced our videos, you know, who's going to own them? Who can use them for what? That's always really critical. A lot of this comes under contracts, so definitely get help with that, which is why working with the university is key, because they have a contracts department. Can take a very, very long time, so think ahead, but definitely get help and advice on that. If you're filming in theatre, if you're filming patients or whatever, if you're filming in general, you know, there are regulations. There's getting access to theatres, there's getting outsiders to come into the NHS, you know, so you need to work with the policymakers and the powers that be to make sure you're doing everything by the books. Agendas and metrics. So as a researcher and as a clinician, you'll have different agendas to a company director, which is absolutely fine. You know, they do have to figure out what's in it for the company. And, you know, it's about communicating openly at the start about what people need, what people want, and what they're going to get out of it. But just bear that in mind and be sensitive to that. Generating evidence. So, I mean, obviously, as a researcher, we need evidence, and I think, you know, you shouldn't do anything unless you've got a decent evidence base behind it. So, you know, can you, in whatever you do with industry, can you generate meaningful evidence that benefits both them and also you from an academic point of view, which is key. Communication I've mentioned, I think that's absolutely critical. One thing to consider is hardware and software updates. You know, every time iOS gets updated or something else gets updated, if it's an application-based solution, you know, that will need to be updated. In your partnership, are you going to get the latest kit if new kit comes out? Are they going to update and manage things for you, or are you going to have to pay for that again? There's just things to think about in that sense. And then ultimately, you want it to be sustainable. You know, you want the medical school to use your solution, or you want the trust to engage into it, or, you know, the hospital that you're working in overseas. So what's the business case and what's the sustainability plan? I think that's really key to think about, and, you know, your industry partners will want that as well, obviously. So so work with them on that. But those are just a few sorts of insights, you know, and it's a complicated world. I think you definitely need a good supervisory team if you're going to work in this space as a student. So as I said, you know, if you need help, make sure you, you know, speak to your supervisors, speak to your sort of the people that are mostly responsible for your education. But in general, the Centre for Immersive Technologies and Leeds Extended Reality Society, you know, these guys are coordinating efforts university level wise, and they've got a wealth of knowledge and a wealth of insight. I guess, you know, you probably know that, hence why you're here, but do reach out to them. And that's all I want to say. And, you know, if there's anything I can do to help, my email address is at the bottom there. And thanks so much for inviting me, Mo and Anna.
That was fantastic. Really good ending there. Thank you ever so much for your time, Will. We've got a question here about the feasibility of virtual reality for usage in investigating social interactions, such as for people with autism. So would you be able to comment on that?
Well, I'm not going to lie to you, autism isn't a surgical disease, and I do focus myself. I do focus myself down. I think is the question mainly around? Can I see the question? Is the question mainly around like design of a feasibility study, or is it feasibility investigating social? Yeah. So I guess I don't know if any of the speakers want to jump in, but just quickly, the angle that I can answer that at is surgery isn't just about delivering a procedure, you know, tying a knot or making this incision or chopping out that tumor. There's lots of non-operative skills, which is, I guess, all the wider side of the, you know, the wider social awareness, spatial awareness, self-awareness kinds of things. So I think, you know, taking the sort of human factors approach, taking the non-operative skills approach, I think that, and I guess Ross's work, he was looking at people observing themselves and gaining greater insights because they're observing it from a virtual perspective, a virtual reality perspective. I think that that to me suggests that social interactions and helping people with difficulties in that, it does sound like it would be feasible in that space.
Can I add to that? Well,
yeah, please do.
I mean, we have it. It's a very interesting question. We were having some conversations today, in fact, with parts of Health Education England around, you know, the area of using VR for teaching psychiatry and all those kind of, you know, non-technical areas. And you know, I think there's I'm sure that I've seen some work somewhere about it, and I think somebody's just put something on the blog saying that Magic Leap, which is the mixed reality headset, works with autism as well. So it's an area following today's discussions I was going to explore anyway. So I'll try and see if I can come up with some answers to that. And we're also talking with Leeds and York Partnership Trust, which is the mental health trust of in West Yorkshire, about similar sort of areas and how we work with them to produce teaching material.
Yeah, and a final point, neurodiversity in general is an enormous topic, and I think the flexibility of VR could have huge potential in terms of opening doors for individuals who might not engage well with a classroom-based learning with lots of people around them, but actually really intelligent in other formats and could engage better with VR. So there's certainly a place where as long as you're not claustrophobic when you put the headset on, that's pretty much the main limitation. Certainly for some autistic children who I've worked with in the past, they like technology, it behaves the way they want it to because they're telling it what to do. Therefore, there's huge scope for VR to be used in autism specifically, but also in neurodiversity more broadly. And certainly, as you say, Gareth, there's apps that you can already use where you can experience a day in the life almost of somebody, a moment in the life of somebody with Parkinson's or something, and it takes you through like a supermarket, and the screen's shaking and you can't really see very well, and there's distracting hallucinations and things. So there's some awesome things to experience from a psychiatry or from a neurodiverse point of view as well. So it's a huge world that VR can definitely take a play in. So if anybody's got ideas or projects, there's definitely things to run with there for sure.
All right, thank you very much, guys. I appreciate the time. So there's just a couple of really important announcements that we have for all the attendees. First of all, we have a post open for a medicine undergraduate faculty rep working within the faculty team in order to represent the medical students, and hopefully we'll grow into dentistry and nursing and so on and so forth. If there are any undergraduate medics listening to us today who would be interested, from the University of Leeds, obviously, please do get in touch with us at leedsxrsociety@gmail.com, or drop us a message on Facebook, and we can give you information on what kind of things we're looking for. Also, we have a couple of important other announcements for opportunities coming up. I'll hand over to Anna, our president, who will give some information about that.
Thanks, Mohammed, and thank you also to you three speakers. It was amazing talks, really interesting. I learned a lot, and so yeah, thank you again for joining us today. Yeah, as you can see, Reese has put in a link to a mailing list sign up form in the chat. If you, in the next 5 minutes, add yourself to our mailing list, you will, one, find out about all the amazing opportunities and upcoming events that we have in store for you. And you will also be entered into a prize draw, which will be announced in 5 minutes, where you could win a plastic phone headset, you could win a Google Cardboard headset, and a Space Team VR key. So that is a game that has been made by Cooperative Innovations, a company that we have been working with recently, and they have created a really exciting game, and this is a free pass to that. So if you want to be entered in to win one of those prizes, do fill out that form. We will also be sending out soon after this event a feedback form. So we like to keep these webinars free because we believe that this amazing XR content should be available to everyone without breaking the bank. So we do really value your feedback. It really helps us to make our events as smooth and as effective as possible. So yeah, check your emails after the event, and yeah, we will go from there.